Hey, today I want to talk about computers that how they can manage to work with just zeros and ones. Because it's the question that cannot be answered very uh, easily, but I'll try my best to explain this in just one video, and then we will continue on Arduino and I will explain our data types after explaining how computers work with zeros and ones. So in real life, when you go outside, you use decimal number system. Decimal number system is based on your fingers. Because you have 10 fingers, we in the past human invented decimal number system. If we had, for instance, 16 fingers, we wouldn't work with tens in that time. We would work maybe with 16s. Every 16 number, we would go a digit higher maybe. So in decimal, we have something like this. You go from 0, 1, 2, 3 until 9, right? And after 9, you go 10. Make it with 2-digit numbers. And after, you go until 99, and then you have 100. You go 3 numbers. You have 3 digits now. And it goes like this. Every time you multiply by 10, you multiply your number by 10, you go 1 digit more. Okay, it is the same thing with 2-digit numbers. In computers, we just have connection and disconnection. We have just two options. Think about this. There's a circuit. This is the plus side, and this is the minus side. So I've talked about the. Let's don't make this minus side. Let's make this out. V out. You have a voltage here. Let's say 5 volts, because your Arduino or most of the CPUs work with 5 volt, but some of them work with 3.3 volt anyway. And you have your ground here, 0 volts. Okay. Now, if you don't connect this, your voltage here is 0 volt, right? But when you connect this, it becomes 5 volts. So you have two options, 0 volt or 5 volts. We call this 5 volts 1, and we call this 0 volts 0. This is digital 1 and digital 0. Your 5 is 1 and your 0 is 0. So you can make lots of stuff. Even this video that you are watching right now is based on this zeros and ones. Is it connected or not? Of course, in computers we don't do this connection with hands. We do this connection with transistors. Okay. We do this with MOSFET transistors. This is not base, gates, and you don't have to know about this. This is the base electronics thing, but I want to make a give you a little information about this so that you can understand what is going on behind the scene. Okay, you have a gate. This gate acts like giving this, opening this with hand and closing this circuit. It does the same thing, but just it works electronically. When you send some signal to this gate, it opens or closes this path here. So it works with this, opening or closing. So everything is based on zeros and ones. Because we can't have any other option, so we say just let's play in this playground, okay? Just instead of being busy with zeros, 1, 10, 2s, 3s, all these decimal numbers, let's just do all our work with zeros and ones. But only 1, 0, and 1 cannot do anything, okay? We can maybe turn on an LED on and off, or we can turn something on and off, but we can't do anything else because we have just two options. But What about if you had 2 digits? 2 of them. Okay? You can make this one 0 or 1. You can also make this one 0 and 1. How many options do you have? So you can make 0, 0, 0, 1, 1, 0, or 1, 1. Now, with having 2 digits, you have 4 options. Let's imagine that we have like 3 of them. You can have 0, 1, 0, 1, 0, 1. Okay? Now you have 0, 0, 0, 0, 0, 1. So now, with 3 digits, you can have 0, 1, 0, 0, 1, 1, and it goes like that until 1, 1, 1. You have 8 options here. And here 4 options. So we call every digit, every single digit 1 bit. Okay? So this is 1 bit, this is 1 bit, this is 1 bit. These bits can be 0 or 1. So with having 2 bits, we could have, with having 1 bit, we had 1 option, 0 or 1. I mean 2 options. With having 2 bits, we had 4 options. With having 3 bits, we had 8 options. Did you realize how it goes? So it is like if you have 8 options, can you say how many? 1, 2, 3, 4, 5, 6, 7, 8. How many options do we have? So if you look at this, if that's 1, we have 2 to the power 1 options here. And here 2 to the power 2 and 2 to the power 3, and it goes like that. If you have 8 bits, you will have 2 to the power 8 different numbers. So it is like 256. So this 8-bit is called a byte. Every 8-bit is a byte. Now, in the early years of computers, the number of bits that a computer could use at the same time was very limited. There were 8-bit computers, there were 16-bit. Now, most of us use like 64-bit computers, and imagine how many options do you have in 2 to the power 64 options. It is a lot. So instead of using decimal based system, we just use twos based system. Okay, we use numbers like this. For instance, 0, 1, 0 is actually 2 in decimal. So you have to learn about two base. It is called binary. So if you want to calculate this number here, you just multiply this first one with 2 to the power 0. You will multiply this one 2 to the power 1 and this one 2 to the power 2. For instance, if you had like 1, 0, 1, 0, what is this number in decimals? So it is like 2 to the power 1 is 2, 2 to the power 3 is 8, so this one is 8, and then you will sum them, so it is 10, like this. So everything works like this. For instance, you want to write on the screen the character C. Okay, you want to write C, right? So there's a table called ASCII table. You can search this on Google. For every character we have some number, an 8-bit number, 1 byte number. And maybe for this it was 114. I don't know for C what is this number, but that's 8 bits, and like this it has, we write this number with binary system, and computer works with this binary system, connects something and disconnect in the CPU, then it writes C for us, for instance. Or on the screen, your monitor, there are little places, okay? Little LED, like some things like LED. And for every of them, there are 3 values, RGB values, okay? This is for red, green, blue. It says how much red, how much green, how much blue. So it begins from 0 to 255, because 255 is the maximum number that an 8-bit, a 1 byte can hold. Because we have 256 options, and with 0 included, the maximum number that you can have is 255. Okay? So we just say this much red, this much green, this much blue. So with every pixel in your monitor, you do the same thing. And you make the second one another value, you make this third one another value, and then you can see a picture. Because with red, green, and blue, you can make every color. For instance, if you make all of them 255, you will get white. This is the last value of them. If you make all of them zeros, then you would get black. And by combining these numbers, for instance, 140, 30, and 55, you can get a color. I don't know what this color is, but if you write this color code on the Google or somewhere, some program, you can find that this is some color, maybe orange, maybe something, I don't know. But for every color, you can make them just with red, green, and blue. So that's how your monitor works. And you see stuff in your screen. So, with binaries, we have made some data types. Because our memory is limited, and it has... our memory works like this. Think this as memory. It begins from 0000. I don't know how much your memory is, your limit is in the memory. I mean, it can go to gigabytes, to terabytes, or it just kilobytes. For Arduino, for instance, it is just 32 kilobytes, I guess. So every 1 bit, so it starts with bits, okay? Every 8 bit is 1 byte. Okay, every 1024 byte is kilobytes, and every 1024 kilobytes becomes megabyte, 1 megabyte, and it goes like this, then gigabyte, then terabyte, and we work with this. So everything starts with 1 bit. 1 bit is means being closed or open, on or off, just this. So now let's go to Arduino. So let's talk about data types in Arduino. So here you can see that when you upload some code, it says it took some bytes and your memory is maximum is 32 kilobytes. Here it says. So Arduino has a limited memory inside it, and it is very small when you compare it with your computer or mobile phone. Just 32 kilobytes. And now we have some data types here. Alright, we have void. Void has size of 0 and range of values. Void is not something for numbers. For instance, you have a function and it is return type can be void and it returns nothing, just empty. We will cover them later when we come to functions topic, and it is not the topic of today. But let's start with integers. So integers take 2 bytes in memory. 2 bytes means 16 bits. Okay. Is there any eraser here? Anyways, so we from the beginning of the course we just used integers, and I said that I will explain integers later. And now it is time. So 16, you have 16 bits of memory for integer, and it has a limited value from minus 32,000 to plus 32,000 and some numbers. Okay, if you put some number bigger than this, it will give you some unexpected values. Okay, but this one is signed. When you declare a variable called integer, it has a sign. Okay, it can be plus or minus. So for being plus and minus, you also give this another bit, the first biggest bit. So you give up from one bit and you make it less with less limit. Okay, you have the same limit, but you have minuses and pluses. But with unsigned int, you can have just from 0 to 65, 2 times of the other one. So, but you have to give up from, you have the trade-off of you cannot have minus numbers, negative numbers here. And word is the same thing with unsigned int. And then you have long. Long has bigger size than integer. Long has 2 times of size of integer, and it can have these numbers, 2 billion. Minus 2 billion to positive 2 billion. And also it has the unsigned type 2, and it begins from 0 to 4 billion. And we have float and double. We use this a lot when we have to calculate some numbers with points, okay, with decimal points. For instance, for int, we can declare a variable called myvar, or just myvar. And if we make it like 11 myvar equals 11.2, and if we try to write this on the serial monitor, let's see. Oh, I didn't put the as you can see here, it writes just 11. It doesn't see the 0.2 because this is an integer. Integer just gets decimal numbers. I mean, it doesn't get the decimal after decimal point. Or if you just let's make myvar 10. Let's make it 10 divided by 4, for instance. It has to be 2.5. But when we upload this, we just see 2, but we had to see 2.5, right? Now we can't see. Why? Because my variable is not it is an integer. It doesn't get these point numbers with points, decimal point. If we make it float, let's see what will happen. So again, it gets not the correct answer. Why? Because we try to divide this, but we had to write 4.0, and I should. Now you can see 2.5. So float works for numbers with decimal points. Also double does the same thing. And then we have string. String is actually a character array, so you cannot say how much is the size, because your array's length can be different with different strings. For instance, if you had 10 letters in a string, its size will be changed, and if you had 15 letters, its size will be bigger and bigger. So it is like this. When we try to for instance have an if statement, okay, if we had an if statement, we can have just zeros and ones, right? This is for boolean, bool or boolean. If you can write both of them, let's write bool. They are the same thing, and this only accepts zeros and ones. So if you have something like if the condition was to make this 0, and if the condition was wasn't to make this 1, or you can get some data and from some digital pin as input, so you can put this into my var, and then according to this you can just here write my var, and you can do some stuff here. We use these boolean variables for if statements, while statements, for loops, and this kind of stuff. Actually not for loop, but for while and if statements we use bool a lot, boolean. So we also have char. Char is for letters and characters actually. You can have a char called x, and its value is, let's say, a, and you can just print out x. Let's delete this. If I upload now, I should see a in the screen. Done uploading. Yeah, as you can see, we just see a's in the screen. So also char takes 1 byte. So that's it for arrays, not arrays. That's it for data types. See you in the next lecture.